Dear students, welcome back. In the previous class, I told you about congruency of triangles, the various criteria for the congruency of triangles like side, 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 or side angle, side, or side angle, angle, or right hypotenuse and side. Now we did few questions based on these criteria on congruency of triangles. Now we'll continue with few more examples. So the first example of the day, there are two lines and these two lines are parallel to each other. There are two more lines and they are also parallel to each other like this. Okay, so this line is parallel to this line and these two lines are also parallel. Now this point, say it is A, this point is B, this point is C, and this point is D. Now there is a line joining A and C like this. There is a straight line joining A and C. Now show that triangle ABC is congruent to triangle CDE. So this is what we have to prove, that triangle ABC is congruent to triangle CDA. Now first of all, we'll make these two triangles separate like this. This is triangle ABC and this is triangle CDA. Okay, ABC, CDA. Now suppose in triangle ABC, angle A, that is angle BAC, and angle DCA will be equal. Why they are equal? Because see, this line and this line, they are parallel and this is a transversal, so these two angles are alternate angles, and you know that alternate angles are always equal when the lines are parallel. That is why these two angles are equal. Means this angle is equal to this angle. The reason also we will write here, angle BAC is equal to angle DCA. The reason, they are alternate angles. Alternate angles. Okay, because these two lines are parallel, this is a transversal, so these two angles are alternate angles, and alternate angles are always equal when the lines are parallel. Okay, then you see AC, you can see AC is common to both the triangles. AC is common. AC is equal to CA. Reason you write down common. Okay, you see this side AC and this is CA. You know that AC and CA are the same thing, so they are equal. So they are AC and CA, they are common, so they are equal. Clear? Next is, you can see this angle ACB and angle DAC, they are also equal. Why? Because they are also alternate angles. See, these two are parallel lines. This is a transversal. So this angle and this angle, angle DAC and angle ACB, they are equal because they are alternate angles. Means angle ACB, this angle, and angle CAD means this angle. So these two angles are equal. Reason again you will write angle ACB is equal to angle CAD. Reason because they are alternate angles. Now you see in these two triangles we have one side equal and two angles equal. So you can say we can apply angle side angle. So the criteria of congruency that we are going to use here will be angle side angle. So the triangle ABC is congruent to triangle CDA. Triangle ABC is congruent to triangle CDA due to angle side angle ASA congruency. ASA congruency. And that is what we have to prove, that triangle ABC is congruent to triangle CDA by ASA congruency. Clear? Now we will do the next example. The next example is okay, now it is given in this question, P is the midpoint of AB. First of all, they have given that P is midpoint of AB. Now they have given that angle BAD is equal to angle ABE. You see, BAD and ABE, these two angles are equal. Okay, and the third thing that they have given is angle EPA is equal to angle DPB is equal to angle DPB. Now these things are given. Okay, the first thing that is given in this question, that P is the midpoint of AB. The second thing, that angle BAD is equal to angle ABE, and the third thing, angle EPA is equal to angle DPB. These three things are given, and now show that first part, triangle DAP is congruent to triangle EBP. Second part, AD is equal to BE. So you have to prove these two parts, that triangle DAP is congruent to triangle EBP and AD is equal to BE. So you have to prove these two. You have to prove these two parts. So the triangles are DAP and EBP. So first of all, we'll make the two triangles separate. In triangle DAP and triangle EBP. So you simply make the two triangles separately. Like this, D A P E B P. Now you see, angle DAP and EBP are equal because they are given equal. It is given. Angle DAP or DAB is the same, or BAD is equal to ABE, means the angle BP. So in these two triangles, first of all you write angle DAP is equal to angle EBP. Reason you write given. Okay. Then angle D. Okay. Now you see these two parts are given equal. Now suppose this angle is X. So you can see that DPA angle and EPB angle are also equal. Because if this is Y and this is Y, DPA will be X plus Y and EPB is also X plus Y. DPA is X plus Y and EPB will also be X plus Y. So you can see that these two angles are also equal. So you write angle DPA is equal to angle EPB. And you can write the reason given, because this part equal, it is given, and then equal part is added to two equal parts. Same angle is added to two equal parts. Okay, so it is given, and now you see AP is equal to PB, because already it is given in the question that P is the midpoint of AB. That means AP is equal to PB. So AP is equal to PB. Third thing, it is given that AP is equal to PB. The reason P is the midpoint of AB. So as P is the midpoint of AB, so you can say that AP is equal to PB. Now you see in these two triangles, one side equal and two angles equal. So it is ASA congruency. The two triangles are congruent by the criteria ASA, angle side angle. So we can write angle to triangle DAP is congruent to triangle EBP, and the criteria will be ASA. It is by ASA. They are congruent by ASA congruency. And now, when it is proved that they are congruent, then by CPCT we can say that AD is equal to BE, because you see AD and BE are two corresponding sides of the two triangles. We have already proved that they are congruent triangles. So by CPCT, that is the corresponding parts of congruent triangles, we can say that AD is equal to BE. So for the second part, you write AD is equal to BE by CPCT, that is corresponding parts of congruent triangles. So AD is equal to BE. The second part is also proved. Clear? Now I will tell you a couple of theorems, and I will give you the proof also. Now, the first theorem is angles opposite to equal sides of an isosceles triangle are equal. So the theorem is angles opposite to equal sides of an isosceles triangle are equal. So suppose ABC is a triangle in which it is given that AB is equal to AC. In triangle ABC, AB is equal to AC. It is given. To prove angle ABC is equal to angle ACB, you have to prove that angle ABC will be equal to angle ACB. So what we do, we have to do a construction in this question. Draw a perpendicular from A on BC. Let this point be P. Let AP is perpendicular to BC. Okay, let AP is perpendicular to BC. Now you can see in this diagram, now there are two triangles, APB and APC. So we will prove the congruency of these two triangles, APB and APC. So in triangle APB and triangle APC, in triangle APB and APC, so you make the two triangles separately. You make the two triangles separately, A, P, B, A, P, C. Okay. Now in these two triangles, AB is equal to AC. It is given. Okay. AB is equal to AC. It is given. AP is equal to AP because they are common. AP is equal to AP because they are common, and angle APB is equal to angle APC is equal to 90 degree because AP is perpendicular to BC. Okay, as AP is perpendicular to BC, so angle APB will be equal to angle APC is equal to 90 degree. Now these two triangles, that is triangle APB and APC, are congruent. Why? Because they are fit in the criteria right hypotenuse side, means RHS congruency. You can see one angle is right angle, the hypotenuse equal, another side equal, another corresponding side equal. So RHS congruency is there, so these two triangles are congruent. Triangle APB is congruent to triangle APC, and the reason will be RHS congruency. They are congruent by RHS congruency. Now as they are congruent, now you can easily say that angle APB, angle ABP is equal to angle ACP. Okay, angle ABP will be equal to angle ACP by CPCT, and that is what we have to prove. Okay, you see, we have to prove that angle ABC or ABP is the same, and ACB or ACP are the same. So you see, angle ABP is equal to angle ACP. We have proved by CPCT. One more thing, although they have not asked for it, by CPCT you can say BP is equal to CP also, and BP is equal to CP means P is the midpoint of BC. So it is also proved that P is the midpoint of BC. So BP is equal to CP by CPCT. So P is the midpoint of BC. Clear? So in an isosceles triangle, the angles, the base angles are equal, that we have proved, and whenever perpendicular is drawn from the vertex on the base, it bisects the base. It divides the base in two equal parts. That is also proved. Clear? Now I will tell you one more theorem, and the theorem is the sides opposite to equal angles of a triangle are equal. So you can see that this theorem 2 is actually converse of theorem 1. Whatever we did in theorem 1, it is the converse of theorem 1. Now see, there is a triangle ABC in which now they have given that angle ABC is equal to angle ACB. Given angle ABC is equal to angle ACB. Okay? To prove AB is equal to AC. Now you have to prove AB is equal to AC. They have given that angle ABC is equal to angle ACB, and you have to prove that AB is equal to AC. So sides opposite to angles are equal. So for that, what we do, you again do the same construction. From A, drop a perpendicular on BC. Let this point be P. Let AP is perpendicular to BC. Let AP is perpendicular to BC. In triangle APB and triangle APC. So now we will make these two triangles separately, APB and APC. APB and APC. Okay. Now in these two triangles, angle ABP is equal to angle ACP, because it is given that angle ABC and angle ACB are equal. So these two angles are equal, and then angle APB is equal to angle APC is equal to 90 degree, as AP is perpendicular to BC. As AP is perpendicular to BC, so these two angles APB and APC will be equal, both 90 degrees. And AP is equal to AP because they are common to both the triangles. So now you can see, like the previous theorem, we cannot apply RHS congruency over here because the hypotenuse is not given equal. So two angles are equal and one side. So angle side, AAS congruency is there. So we can say triangle APC is congruent to triangle APB is congruent to triangle APC. Triangle APB is congruent to triangle APC, and that is by angle side, AAS congruency. And when it is proved that they are congruent, then by CPCT we can say that AB is equal to AC. That is what we have to prove. So AB is equal to AC by CPCT. Okay, that means we have proved that in a triangle, if two angles are equal, then the sides opposite to the angles are equal to each other. Clear? Now we will do few examples based on these theorems. Question is ABC is an isosceles triangle, means it is given that AB is equal to AC. It is given that AB and AC are equal. Okay. Now a perpendicular is dropped from B on AC. It is BE, and another perpendicular is dropped from C on AB, that is CF. Okay. In other words, we can say that BE and CF are the altitudes of the triangle. Now prove that BE is equal to CF. Prove that BE is equal to CF. You have to prove that BE and CF are equal to each other. So first of all, in triangle BEC and triangle CFB, in triangle BEC and CFB, so you make the two triangles separately. Like this, BEC and CFB. These are the two triangles. Now you can see BC and CB. They are equal because they are common to both the triangles. This angle 90 equal to both the triangles, and in triangle BEC angle C and in triangle CFB angle B, they will be equal because using the theorem 1, in a triangle angles opposite to equal sides are equal, that or the base angles of an isosceles triangle are equal, so these two angles will be equal. Clear? So BC is equal to CB, reason they are common. Then angle BEC is equal to angle CFB is equal to 90 degree. It is given. Then angle BCE is equal to angle CBF. Reason, base angles of an isosceles triangle. That is actually the theorem 1 that we have already proved. So base angles of an isosceles triangle, so they are equal. The base angles of an isosceles triangle are equal. Now you see two angle one side, so AAS congruence is there. So we can say that triangle BEC is congruent to triangle CFB by AAS, angle side, AAS congruency. And once it is proved that they are congruent, then by CPCT we can say that BE is equal to CF. So BE is equal to CF by CPCT, and that is what we have to prove. Okay. Clear? Now the next question. Next question. There is a triangle ABC. in which it is given that AB is equal to AC. Now BA is extended such to the point D such that AC and AD are also equal. Okay, so AB and AC are equal in a triangle ABC. AB and AC are equal. Then BA is extended to a point D such that AD and AC are also equal. Now you join DC. Prove that angle BCD is equal to 90 degree. Okay, so you have to prove that angle BCD means this angle is 90 degree. You have to prove that this angle is 90 degree. Now you see, in triangle ABC, angle ABC is equal to angle ACB is equal to X. Base angles of an isosceles triangle. Okay, angle ABC is equal to angle ACB is equal to, we let that angle is X, and why they are equal? Because they are base angles of an isosceles triangle. Now in triangle ACD, angle ACD is equal to angle ADC is equal to Y. The same reason, base angles of an isosceles triangle. Base angles of an isosceles triangle means this angle and this angle, they are equal, and we assume these angles to be Y. Now in triangle BDC, angle B plus angle D plus angle C is equal to 180. That is the angle sum property of a triangle. Angle sum property of a triangle. Angle sum property of a triangle. Now angle B is what? X. Angle D is Y. And angle C is X plus Y. Means 2x plus 2y is equal to 180. If we divide the whole thing by 2, then we will have x plus y is equal to 90 degree. But x plus y is nothing but angle BCD. You can see x plus y is nothing but angle BCD. So angle BCD is equal to 90 degree. Proved. And this is what we have to prove. Clear? We have proved that angle BCD is 90 degrees. Now the next question. In the next question, ABC is a triangle, DE is an altitude on AC, and CF is an altitude on AB. Now it is given that BE is equal to CF. They have this time they have given that BE is equal to CF. Prove that triangle ABE is congruent to triangle ACF. This is the first part, and second part, AB is equal to AC. So there are two parts of the question. First part, prove that triangle ABE and ACF are congruent, and second part AB is equal to AC. So in triangle ABE and triangle ACF, in triangle ABE and triangle ACF, first of all we will make these two triangles separately. ABE and ACF. So we will make the two triangles separately. Now BE is equal to CF, it is given, and BE is equal to CF given, one angle 90 degrees is given, and angle A, you can see this angle A is common to both the triangles. Okay, so the reasons are, first of all you see, BE is equal to CF given, angle AEB is equal to angle AFC is equal to 90 degree, again given, and angle BAE is equal to angle CAF, angle BAE is equal to angle CAF because they are common. See, angle BAE means this angle, CAF means that angle only. So that angle is common to both the triangles, so they are equal. Now you see one side and two angles, means side angle congruence is there. So we can say that triangle ABE is congruent to triangle ACF by SAA congruency. Side angle congruence is there. Side angle. Okay. And once it is proved that these two triangles are congruent, then by CPCT we can say that AB is equal to AC. If this is proved, now AB is equal to AC by CPCT. So the second part is also proved. Clear? Now the next question. In the next question, ABC is a triangle which is right angled at A, and it is given that AB is equal to AC. So find angle B and angle C. You have to find angle B and angle C. In this diagram, there is a triangle ABC in which angle A is 90 degree, and it is given that AB is equal to AC. So angle ABC will be equal to angle ACB is equal to X. Base angles of an isosceles triangle. So we are applying the theorem 1 again. This is an isosceles triangle, these two sides are equal, side angles opposite to equal sides are equal, so these two angles are equal. We have assumed them to be X. Now in triangle ABC, 90 plus X is equal to 180. That is the angle sum property of a triangle. 90 plus X is equal to 180. That is the angle sum property of a triangle. Now X plus X, 2X is equal to 180 minus 90. So 2X is equal to 90. So x will be equal to 90 upon 2, that is 45 degree. So you can see that angle B and angle C both are equal to 45 degrees. Angle B is equal to angle C is equal to 45 degrees. That is your answer. Okay, so today I told you two theorems and we did few questions based on those theorems. Now in the next period we'll continue with few more examples and a few more theorems probably. So what do all the sums that are given in the assignments, they are very important questions and they will make the topic clear. So make sure that you do all the sums given in the assignments. Okay.